This video focuses on linear inequalities and how to solve them. The inequalities that we're going to deal with are just single variables for this video here. So our inequality signs are less than, greater than, less than or equal to, or greater than or equal to. So they're very similar to equations, except instead of an equal sign, we have an inequality sign instead. So there's a few examples for you. So we're going to be focusing on solving these single variable inequalities in this video. So when we're looking at the solutions of an inequality, it gives us a range of options. So whereas when we have an equation and I say x equals 7, well then the only value that x could be 7. But if I throw in an inequality here and I say, well, x could be less than 7 or equal to 7, it would represent something that looks like this. So it could be any number that falls below 7, but it could also be 7. So take notice of the dot. So because my dot is filled in, then that means it could be less than or equal to or greater than or equal to. So in other words, it has this or equal to line under it. If I have an open circle, such as in this one, it is saying that x could be greater than or less than, which means it couldn't be -4, but it could be anything above -4. So we have a closed circle and an open circle. So if I wanted to graph the solution, or what the solution would look like for -2 is less than x, which is less than or equal to 5. Sorry, a positive 5. So I look at my number line here, and here would be 0. -2 would be right here, and 5 would be right here. So because this says that -2 or x is greater than or less than -2, so I'd read in that direction. Because it doesn't have a line under it, I'm going to put an open circle at -2. Because this has a line under it, it's saying it could be 5. And then of course it could be anything in between here. So it would look something like this. So pay attention to the, does it need an open circle or does it need a closed circle? So for looking at solving these inequalities, we're going to use similar strategies as if you were looking at an equation. So we want to make sure that we get the variable by itself, and we do that by doing the opposite operation. So we add, subtract are opposites, multiplication and division are opposites. The only difference here with the multiplication and division property is that this number 2 here. So we need to take special note of this. So if I want to multiply A is less than B, if I want to multiply both sides by C, I could do that and nothing would happen. It would keep everything equivalent. But that only works if it's a positive number. So if I want to do the same thing, but I want to multiply it by a negative number to each side, notice what it does to the inequality. It flips the direction. So this is going to work for multiplication or division. So if you multiply or divide by a negative number, you flip the inequality. So let's look at some examples. So I have 5x is greater than -20. So to solve this, I want to get x by itself. So I'm going to divide by that coefficient. And because that coefficient is positive, I don't have to flip the direction. And I do the same thing to the right side, which would give you a -4. So if this coefficient was negative, I would flip the direction, but it's not, so it stays the same. So take note of this next one. So I have -1/2 x is less than or equal to -12. So I want to divide by this coefficient because multiplication, opposite division, so that is cancel. But because that coefficient is negative, I now have to take this inequality and flip it. Notice I didn't change the fact that it had a or equal to sign underneath it. I just flipped the direction. And then divide this side by negative 1/2 as well. So negative divided by negative is positive. 12 divided by 1/2 would give you a 24. And that would be your answer. Okay, so again, because this was positive, I didn't flip. This was negative, so I had to flip. Let's look at a couple more. So we're going to look at using both properties, or a two-step or multi-step. So I want to add, if I'm adding 8, let's subtract 8. That leaves me with 3x is greater than or equal to, and 5 minus 8 is negative 3. So now I'm going to divide by the coefficient, and because that coefficient is positive, the direction of the inequality stays the same, and that's going to give me a negative 1. So very similar strategies as if you were solving a one-variable equation. We just have an inequality sign instead. Okay, let's look at the next one. So this one's going to take us a couple steps to do. So the first thing we're going to do is let's distribute this out. So I'm going to keep that 3x plus 9 is greater than, and then distribute and get that. Now I want to get the x variable terms on the same side, so I'm going to go ahead and pull this negative 3 or minus 3 over. So that cancels, leaving me with 9. And again, I haven't multiplied or divided anything, so the direction of my inequality is going to stay. 5x's minus 3x's would give you 2x's. Now we'll go ahead and add 5. And you're going to get 14 is greater than 2x. Divide by 2, and again, because the coefficient is positive, I keep the direction, I don't flip, and I'm looking at 7 is greater than x. Now, let's talk about how I could write this with the variable term first. So if it's 7 is greater than x, I don't want to just flip the x in the 7 and say x is greater than 7. So notice I kept the sign but just changed the 7 in x. That's incorrect. Notice when you're looking at this inequality, the inequality sign is open to the 7. So then when I go to rewrite it in this form, I have to make sure that it's still open to the 7. So if I want to put the variable term first, I have to make sure that the mouth of your inequality is still open to the bigger number. So pay attention to that if you go to write it in the other direction. Sometimes you're going to have to do that. All right, go ahead and pause the video and try these two. They are multi-step. They're a little bit more difficult. So make sure you're simplifying both sides of the inequality, getting the variable terms on the same side, and then you can go ahead and play it and hear the explanation. All right, let's look at the first one. So I have 9 plus 5 is less than or equal to 2x minus 5 plus 3. So first thing you wanted to do was to simplify the left side, simplify the right side. So 9 plus 5 is 14, less than or equal to. And then on this right side, the 2x doesn't have any like terms, but the negative 5 and the plus 3 right here, I can simplify that to a negative 2. So that should have been your first step there. Now I can work to get that x by itself. So let's add the 2. And I get 16 is less than or equal to 2x. Now let's get rid of that coefficient of 2 by dividing. And that leaves you with 8 is less than or equal to x. And again, as I said on that last slide, if you go to write this with the x first and the 8 last, notice the inequality is open to the x, so it needs to continue to stay open to the x. Okay, so that would be the proper way to write it. So make sure you understand the difference between. All right, let's look at the next one. All right, the next one has lots of steps, so let's go through this one. All right, so let's go ahead and distribute on both sides first. And then we'll look to combine like terms. So 7 times negative x is negative 7x. 7 times negative 2 is negative 14. Drop down the plus x. Distribute on the other side, so that would have given you a negative 20. A negative 4 times a negative x gives you a positive 4x, so make sure you change that sign because a negative times a negative is positive. And then drop down the minus 12. All right, so after you distribute, then we'll look to combine like terms. So let's look on the left. So these x's can go together. So negative 7x plus x, that would give you a negative 6x minus 14. On the right side, your constants are the like terms. So negative 20 minus 12 gives you negative 32. And then drop down the 4x. Okay, so we distributed, we combined in like terms, and now let's get the variables on the same side. So you could go either way. So let's go ahead and subtract the 4x. You did not have to do this. You could have taken the negative 6x over and added 6x, which would have been fine as well. So this leaves me with negative 10x minus 14 is greater than negative 32. So we'll add the 14 to pull that over. You get negative 10x is greater than negative 32 plus 14. That would be negative, let's do the math here. Be 18, negative 18 is what you would get there. Now let's divide by the negative 10. Now because I'm dividing by a negative, I'm going to flip the direction of that inequality. And then you're going to be left with 18 over 10, or that's going to be 1 4/5. Or if you had it as a decimal, it would be 1.8. And again, a negative divided by a negative is positive. Good. Okay, so let's look at some word problems with these. So for these, we're just going to have to set up the word problem as an inequality. So we want to look for clue words there. So some of our clue words are at most or at least. And these are kind of opposites. So when you think of at most, you would think most is greater than, but it actually is a less than or equal to sign. And at least would be a greater than or equal to sign. Okay, so those are two of the biggest ones there, because sometimes we get hung up on the most and the least. Okay, so this one says you are having a catered event. You can spend at most $1,200. The setup fee is $250 plus $15 per person. Find the greatest number of people that can be invited and still stay within the budget. Okay, so let's start here. So at most $1,200. So at most is less than or equal to, and then the $1,200 would be my at most budget, my max budget. So the setup fee is $250 plus $15 per person. So that would be $250 plus, and then $15 per person would be 15 P, because we're not quite sure what the greatest number of people is we can invite. Okay, so let's solve it. So subtract 250. That leaves me with 15P is less than or equal to, that'd be 950. Now we're going to divide by the 15. And that's P is less than or equal. I'm going to keep the same direction of the sign because that coefficient was positive. 950 divided by 15 would give you 63.3 repeating, or as a fraction, it was 63 1/3. So to answer the question, it says find the greatest number of people that can be invited and still stay within the budget. Obviously, we're not going to invite 1/3 of a person, so I can't invite 64 because my number isn't high enough to invite 64. So the max number of people, the greatest number of people that I could invite would be this whole number of 63. So 63 people could be the max that I could invite and stick within that $1,200 budget. All right, the next one. Alex earns $600 per month plus 4% of all his sales. Find the minimum sales that will allow Alex to earn at least $3,000 per month. Again, we'll start here because this is our total. So at least, again, is greater than or equal to, and then the 3,000. So Alex earns $600 per month plus 4% of all his sales. So no matter what, we got $600. And then we're going to add to that 4% of his sales. We just don't know the minimum sales that he needs. Okay, so we got 600. I'm going to change this percent to a decimal. You don't necessarily have to if you're using a calculator. Make sure that you use the percent symbol to put that in. If you're not using a scientific calculator that has a percent symbol, make sure you change it to a decimal when you're doing the calculations. So we subtract the 600. I have my 4% S greater than or equal to 3,000 minus 600 is 2,400. And then we're going to divide it by this 4%. And again, because the 4% is positive, I'm going to keep the same direction of the sign. And that's going to give me S has to be greater than or equal to 60,000. Let me double check my math. And yep, that's what I get. So S has to be greater than or equal to 60,000. So the minimum sales, in order for him to get $3,000 per month, he's going to have to sell at least 60,000. So he could sell 60,000 or anything above would give him that monthly payment. All right, go ahead and pause the video and attempt this word problem. I have another one for you next, but we'll take them one at a time. So go ahead and pause it. Try it, write out the inequality, solve it, and then hit play and see and compare what we got. Okay, so for this one, we had an at most 1,000. So again, that's less than or equal to 1,000. And then it says the reception hall charges $100 cleanup fee plus 14 per person. So that would be $100 no matter what. And then 14 times P for the number of people. All right, so we subtract 100. Get 14P is less than or equal to 900. Go ahead and divide by that 14. And you get P is less than or equal to 64.28 ... Okay, so it gives you a long decimal there. But it's okay because I don't really need the decimal because I'm not going to invite a fraction of a person. So the greatest number of people that they can invite and still stay within their budget would be the whole number of this 64. So 64 people would be your final answer there. Very good. All right, go ahead and pause and try this one. All right, this one's slightly different, but not in the sense that we're looking at an at least. So at least that would be greater than or equal to 180. So he wants his average bowl to be 180 or better. So Ben bowled 146, 201 his first two games, and we're trying to figure out that third game. So this one was reviewing here with this average. So the average is, then you add them all up, divide by however many numbers. So he had a 146 plus a 201. Well, I don't know his third game, so I'm going to give that a variable. So 146 plus 201 plus B would be the sum of all three games. And then because I'm looking at the average of that, I'm going to divide by those three games because that's what we're looking at. So that's what your inequality should have looked like, setting it up with that average. Okay, so now to solve this, I'm going to go ahead and times by 3 first. So that divided by 3, let's get rid of that because then it's going to leave you with everything on top Now you could have added these first before you did anything. That would have been fine too. And that would give you 540. 146 plus 201 would give you 347. Okay, so that's where we're at. Oops. I'll go ahead and subtract 347. So that means B would have to be greater than or equal to. So remember, B is his third game. So his third game would have to be greater than or equal to 193. So he could bowl 193, he could bowl 194, he could bowl anything higher, and then he's going to at least get the 180 or better. Very good.